Hey guys, so today we're going to be taking a look at the Alka-Seltzer lab. The objective here today is to understand the chemistry or science behind a lava lamp and what really makes it so special. So, there are three parts of a lava lamp. First is where there are separate components and neither of them have experienced a chemical or physical change. Secondly is where the components have made contact with each other and formed a reaction. The third stage is where the components or certain components have blended with each other and created a new mixture. So, the first stage is before. As you can see, the water in the bottle has not made contact with the oil or food coloring yet. This makes it a pure substance. In the second picture, you can see that we have poured the oil into the bottle. The oil sits on top of the water because it has less density or is less dense. Okay, density means the amount of compactness in a substance. It can be liquid, solid, or maybe even gas. And the water is more dense, meaning that it will sit at the bottom of the oil because its density is higher, meaning it's more compact. Okay, even though both liquids still remain as substances and have not bonded with each other, they form a type of mixture called a heterogeneous mixture. A heterogeneous mixture is a type of mixture where you can easily tell apart the different components. For example, here you can clearly see the oil and the water apart. This also means that it is easier to separate or bring the substances back to its original form. Okay, the second stage is during. So as you can see, there have been a couple of food coloring drops mixed in with the water and is slowly starting to blend in. The food coloring does not color the oil because it has a similar density with the water, which allows the food coloring to sink through the oil and settle in with the water, meaning that it also has low solubility in the oil since it won't dissolve in the oil at all. Okay, so in the second picture, you can see the food coloring has completely blended in with the water, forming a green water. Now, some people argue that this is a chemical change, but some people say it's a physical change. Now, it is a physical change if you can separate the food coloring from the water, but it is a chemical change if you cannot separate those two parts, meaning that they're fully bonded with each other. Okay, this forms a homogeneous mixture. So the green water is basically a homogeneous mixture because you cannot completely identify the food coloring by itself and the clear water by itself, meaning that it is also harder to separate the two components back to its original state. However, the food coloring has not affected the mixture of the oil and water, but because you can still tell apart the green water from the oil. Okay, so then we took an Alka-Seltzer tab and broke it up into 4 different pieces, meaning that the Alka-Seltzer tab went through a physical change. A physical change is where only the appearances, shape, texture, or size has changed, and its original formula of the substance itself hasn't really changed. Okay, then we dropped each individual piece into the bottle one by one while observing the reaction. As the Alka-Seltzer tab made contact with the water, it started releasing gas, which encourages the water to float up into the oil layer but then sink back down. This is a chemical change because the water took a new substance, which was the gas from the Alka-Seltzer tab, and was mixed in with the water. Okay, this is sort of forming a new mixture because a new substance has been introduced into the water. However, it is still a heterogeneous mixture apart from the oil and water because you can still see the two different components very clearly. The Alka-Seltzer tablet and the water have formed a solution. And a solution is made up of two parts, the solute, so the component that's being dissolved, which would in this case be the Alka-Seltzer tab, and a solvent, which is the substance dissolving the solute, which would be the water. Okay? Now let's break it down to see the final stage of after. Okay, so here we have our two layers, the water layer, and the oil layer. First, we can tell apart these two layers, which makes it a heterogeneous mixture. But after the green food coloring was added, that still did not change. Only the water itself changed, turning into a homogeneous mixture because you could not tell apart the food coloring and the water itself. Okay, and then we broke an Alka-Seltzer tab, which went through a physical change, and it sunk to the very bottom because it had higher density. It released carbon dioxide bubbles, which pushed the water up into the oil. However, the water droplets still sank back down because the gas from the Alka-Seltzer tab did not affect the water's density, meaning that even though the water had the gas to push it up, it would still fall back down because water still has a higher density than oil. Okay. Until the Alka-Seltzer tab was completely dissolved, there would be no more gas bubbles were being released, which puts an end to the reaction. But as long as you had an Alka-Seltzer tab in the bottle, it would create that lava lamp effect. Okay, so in conclusion, there were multiple pure substances to begin with. For example, the oil, food coloring, water in the tablet itself. Okay, and none of the components have bonded together, which really makes a substance pure. Then when they were mixed together, there was a solute and solvent, which created or formed a solution. Certain components experienced a chemical change, and certain components experienced a physical change. Okay, sorry I can't get that but just to let you know, it says physical change. Okay, finally there was a new mixture formed where the gas from the Alka-Seltzer tab blended in with the water. Hope you guys now know the science behind a lava lamp.